Welcome back. We're ready to begin Chapter 2 of Honors Pre-Calculus. Chapter 2, Section 1 is titled Polynomials. This is Part 1. A polynomial is any expression of this big form right here. Now, don't let that intimidate you. All that is a generic form of a polynomial, where you have a leading coefficient, a constant, and everything in between. Some examples are x squared minus 6x plus 2. That's a quadratic polynomial. You've already worked with those. Or 3x to the third power plus 2x squared minus 7. That's a cubic polynomial. Something that's not a polynomial would be 2 over x cubed. Okay, the problem there is you've got a variable in the denominator. Or another way to think about it is you have a variable with a negative exponent. You might want to jot that down because this is the same thing as 2x to the negative third power. Anything with a negative exponent in the numerator is not a polynomial. This one, same thing. This is not a polynomial because it's not continuous. In this particular polynomial right here, x would not allow to be negative 2. It has what we call a discontinuity. That's what makes it not a polynomial. If, for example, you had this polynomial right here, 4x to the fifth power minus 2x cubed plus 7x squared minus 3. If you were to label these vocab terms, the constant is a sub 0. It's the last term, in which this case it's negative 3. It's the term that does not contain a variable. The coefficients are all the a sub n's. A sub n minus 1, which is the second one, a sub 2, which is the third to last one, a sub 1, etc. Those are the coefficients. And in this particular case, it'd be 4, negative 2, 7, and negative 3. Let me list those for you. 4, negative 2, 7, and negative 3. Those are the coefficients. They are with, I'm sorry, negative 3 is a constant. I shouldn't put that as a coefficient. That's bad. They're the numbers with variables. The leading term is the term that contains the highest power of x. And in this case, it'd be 4x to the fifth power. It's not always the first term. It's the term with the highest power. And then finally, the degree. The degree is the highest power of x. Well, in this case, the highest power of x we see is 5. This would be called a quintic polynomial. And then finally, a root of a polynomial is any place where the function can equal 0. In other words, where it crosses the x-axis. To find a root or to find a 0, set the function equal to 0 and figure out where it crosses the x-axis. Solve for x. Okay, so here's a function, and we're going to sketch the graph here in a little bit. P of x equals 2x cubed minus 32x. Now, the highest power, the degree, is 3. That means it has 3 roots. Or you could say zeros. 3 roots or zeros. I want you to find the zeros. Now, I also want you to ask the question, is it a polynomial? Well, are there any variables in the denominator? Nope. So we would say yes, it is a polynomial. No negative exponents, no variables in the denominator, only one variable. Definitely a polynomial. I want you to find the roots, and I want you to try factoring first. Maybe there's a GCF that you can pull out. That's what you should always look for. So, to find the roots, we have to set P of x equal to 0. In other words, replace P of x with 0. In other words, set y equals 0. And you know what? There's a GCF of 2x. Pull it out, set it out front. That leaves you with x squared minus 16. All I did was divide by 2x. Well, that factors even further because x squared minus 16 is a difference of squares. That becomes x plus 4 and x minus 4. And looky there, our roots are negative 4, positive 4, and by the way, this x right here, it could also equal 0. Those three values of x will make this polynomial equal 0. Okay, so we're going to sketch this graph on the calculator first. I've already typed it into my y equals menu. Now I'm going to hit graph, And looky there, that's what it looks like. And notice, it crosses the graph 3 times at -4, 0, and +4. So let's go ahead and sketch the graph ourselves. Plot your zeros first. The first one is at -4 right here on the graph. Second one's at 0, and then there's one at 4. Now, a cubic function starts out usually going up, comes back down, and goes back up. It looks kind of like a sideways S, or an S that's been turned on its side. Now, I know it starts down and finishes up because the leading coefficient is positive 2. If you see it right here, see that positive 2? If that were a -2, then it would be backwards. It would be the other way around. So here's the next one. So this one's a little bit different than the last one we looked at. The first thing I want you to answer is this g of x equal to x plus 1 over x minus 1? Is it a polynomial? And the answer is no. The reason the answer is no, because we have a variable in the denominator. Also, I want you to note that the degree here is 1. The highest power you see is 1. That means there's only one root, or 1, 0, or one place this crosses the x-axis. Now let's find that 0. In other words, what values make the right side equal 0? So let's set this equal to 0. 0 equals x plus 1 over x minus 1. Now, what you can do here is multiply both sides by the denominator, since it's equal to 0 and nothing else. Well, 0 times anything just stays 0, so 0 is equal to x plus 1. And the 0 for this expression or equation is -1. One little side note here. G of x, we say, is undefined for x equal 1. And think about this. If you plugged in 1 to the original polynomial, you would get 1 minus 1. And you guys are not allowed to divide by 0 because you are not who? That's right. You are not Chuck Norris. So again, what I've done here is I've typed the equation into our calculator, and I just want to take a look at this graph. So let's hit graph, and look, you can see the curve. It's going to come in, it's going to go down, and then boom! It's got this line going straight up and down. What that's called is an asymptote. And look where that happens. That happens right there at 1. In fact, if you go to your table, look right here at x equal +1. You get a big fat you get an error because x is not allowed to be 1. Every other value is defined. That's called a point of discontinuity. That's why this polynomial is not, that's why this equation is not a polynomial. So we want to take the time now to fill out a chart. You're probably going to have to pause the video to catch up with me. We're going to talk about a few different types of polynomials. The first one is a constant polynomial. A constant polynomial. It has a degree of 0, and here's an example. It's just a constant function. It's, equal to 5, or you could even say 5x to the 0 power if you wanted to. And it's a horizontal line if you sketch it. We talked about those in chapter 1. Secondly, what if you have a linear polynomial? Well, it's got a degree of 1. An example would be f of x equals 2x plus 5. You should recognize that as slope-intercept form. It's to the first power, that's the highest power, and it's just, a line. It has slope. Degree 2 would be a quadratic polynomial, and this would be, f of x equals 3x squared plus ... The point is, the highest power you see is 2. And it looks like a parabola if you graph it. Could face up, could face down. And you should know that from chapter 1 as well. If you have a cubic polynomial, the highest power you see is 3. It means you have 3 zeros. They might be real or complex. That would be if you have like 5x to the third power plus, ... And usually they look like sideways S's, something like that. If they're positive, they finish up. If they're negative, they finish down. If you have a quartic polynomial, then you have f of x, equals x to the fourth power plus something. These kind of look like W's. If they have a negative leading coefficient, they open down. And then finally, if you have a quintic polynomial, then you have f of x is equal to x to the 5th power plus, dot, dot, dot. And these are a little trickier to draw. They go up and then back down and then back up and then back down and then up. That's if you have a positive leading coefficient. If you have a negative leading coefficient, it goes down, up, down, up, down. They have 5 zeros. 5 zeros. So let's do a couple examples here. If g of x is equal to 5, tell me if it's a polynomial function. Determine if it's a polynomial function. Well, g of x equals 5, let's see here. What is that? That means that just says y equals 5, right? Well, what's that look like if you sketch it? 1, 2, 3, 4, 5. Chung, 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 chung. You've seen that before. This is one of those special guys. It's a horizontal line. Now, think of this as 5x to the 0 power. That means it has 0 roots. It never touches the x-axis. And that's true because if you plug in 0 for y, you're never going to get this function to equal 5. It ain't going to happen. So we say that there are no zeros. There are no zeros. But is it a polynomial? Is it discontinuous anywhere? No, it's defined for any x value. So we're going to say yes, it is a polynomial, but it has no zeros. In the second function, go ahead and set it to 0 to try and find its zeros. How do you get rid of that 2? Well, you just multiply both sides by 2. That's pretty easy. Here, I'll show my work. Times both sides by 2. Now it's equal to x squared plus 4. Subtract the 4. Now it's equal to negative 4. So x could be plus or minus, 2i when you take the square root? Plus or minus 2i. So those are the zeros. They're complex, which means you won't actually see them if you graph it. Is it a polynomial? Does it meet the conditions? Are there any variables in the denominator? No, there aren't. So you know what? We're good to go. Yes, this is a polynomial. No variables in the denominator, and there's only one variable, x. Okay, we're going to finish this video off with just a few more examples. If p of x is a quartic polynomial that says 3x to the 4th minus 7x cubed minus 5x squared plus 9x plus 10, find p of 2. Well, that's pretty simple. That just means to plug in 2 everywhere you see x. So we would have 3 times 2 to the 4th power, minus 7 times 2 to the 3rd power, minus 5 times 2 to the 2nd power, plus 9 times 2, plus 10. And when you punch all that into your calculator, you do it by hand, you're going to get 0. That means p of 2 is 0. That means 2 is a 0 of this function. It's a root. It's an x-intercept. If you graph that function on your calculator, it's where it will cross the x-axis. If you look it up on the table on your graphing calculator, the columns will say, in the x column, it'll say 2, and in the y column, it will say 0. That's exactly right. Okay, let's try one with a variable. So plug in negative 3n everywhere you see an x. So 3 times negative 3n to the 4th power minus 7 times negative 3n to the 3rd power minus 5 times negative 3n to the 2nd power plus 9 times negative 3n plus 10. And now just watch your order of operations and make sure you simplify. Negative 3 to the 4th is a positive 81 times 3 is 243 n to the 4th power. Negative 3 cubed is negative 27, but when you take it times negative 7, you get positive 189 n to the 3rd power. Negative 3 squared is 9 times negative 45 is negative 45n squared. 9 times negative 3 is minus 27n, and then plus 10 is just hanging out by himself. There you go. That's p of negative 3n. That's the output. Now in part C, find the output when you plug in 2i. So we've got the complex unit going on here. So 3 times 2i to the 4th power, minus 7 times 2i to the 3rd power, minus 5 times 2i to the second power, plus 9 times 2i, and finally plus 10. Now you would be done, except you need to remember everything you learned in chapter 1 about the complex unit. 2 to the 4th is 16. 16 times 3, 48i to the 4th. 2 to the 3rd is 8, times negative 7 is negative 56i to the 3rd. 2 to the 2nd is 4, times 5 is negative 20i to the 2nd. 9 times 2 is 18i, plus 10 is still hanging out. I to the 4th power, you remember, is just 1. I to the 3rd power, negative I. I to the 2nd power is negative 1. So, now that you remember all this, simplify. So we got 48 plus 56i, because 2 negatives, plus 20, because 2 negatives, plus 18i, plus 10. And now just combine your like terms. So 56i and 18i is 74i, and 20, 10, and 48 is 78. There you go. And again, you could actually have done that one on your calculator as long as you were in A plus BI mode. That's a good way to check your work. Okay, last example, and I really, really like this problem. I guarantee you're going to see this problem on a quiz or a test of some kind. Here's the problem. Read along with me. If 2i is a 0 of this function, x to the 4th plus x squared plus a, find a. Figure out what a is. Well, let's talk about what this means. If 2i is a 0, then what that means is that when you plug in 2i, when that is your input, then you get what for an output? You get 0. 2i is a 0, that means you get 0. 2i is a 0, that means you get 0. Kind of making up a song. I kind of like that. I might sing that song to my son tonight. Anyway, so we're going to replace y with 0 when we plug in 2i. When you plug in 2i, you get 0. Tell yourself that. Everywhere you see an x, put 2i. And now you just solve. It's that easy. So this really says 16i to the 4th. That really says 4i squared. Well, 16i to the 4th is 16. I squared is negative 1, so that's minus 4. Check me on that. Make sure you understand that. Well, that just means a must be negative 12. Boom. That's simple. Not a hard problem. The hardest part is understanding this right here. Do you know what this means? Do you know what they're telling you if 2i is a 0? Well, that means y is 0 when I plug in 2i for x. Might want to write that down. All right, that's all I got for section 1, part 1. Have a great night. I'll catch you later. I'm out.